we have studied about the fundamental units, or the units which do not depend on any other units. We saw that the units for length, mass and time were the fundamental units. And in order to define these fundamental units, several systems were developed. But what was there before these systems was developed? What was there in the olden times where there was no particular standard measurement for length, mass or time or any other particular quantity? Let's consider a time in the olden days. So let's say there is a furniture merchant who sells furnitures. Now he travels from his own town to another part of another town. Now in that town he comes across a buyer. Now this buyer is interested to buy furniture from this particular merchant. Now this merchant sells a particular table to his buyer, saying that the length of the table is 10 handspans. Now the buyer is satisfied, saying that it's quite a big table, but the buyer goes back home after taking the table and he finds it is only 8 handspans and not 10 handspans. So the buyer was infuriated. He thought that the merchant had tricked him, and he was so furious that he did not know what to do with the table. So now I ask you, do you think the merchant had actually tricked the buyer, or do you think that the buyer was lying? The truth is, it was neither. The length of a handspan for the merchant was shorter, so he took more handspans to cover the entire table, whereas the length of a handspan for the buyer was longer, so he took less handspans to cover the table. So as you can clearly see, handspans, feet, cubits, these are not standard forms of measurements. So in order to standardize measurements and come up with something that can be used by everyone, certain conferences and meetings were held. A notable conference was held in the year 1889. In the year 1889, first step towards international standardization of units was taken. But despite the huge conference in 1889, it was found out that several anomalies were still left behind. So another conference of importance was conducted after the World War, sometime in the 1960s. At that conference, a concrete framework of international standard units was drawn up, and it was proposed that this system of units should be applicable across countries in the world. This system is also known as the Standard International, or abbreviating it, the SI system. Now the SI system proposed that there should be certain quantities which should be applicable all across the world, and these are the units or the quantities that it proposed. Length should be measured in meters, given by the symbol M. Mass should be measured in kilograms, given by kg. Time should be measured in seconds, given by S. So we know from our previous discussions that these three comprise the fundamental units. In addition to these units, the SI system proposed that more units be taken into consideration. So the other units were temperature, where Kelvin was to be the unit represented by K, luminous intensity, candela being the unit represented by CD, electric current, ampere being the unit represented by A, and lastly amount of substance, mole being the unit represented by MOL. So these were the physical quantities that were proposed by the Standard International System Conference that was held sometime in the 1960s. So let us see how the SI system defines length. Now according to the SI system, length is measured in meters. So how is 1 meter defined? 1 meter is the distance between two marks drawn on a platinum iridium, that is an alloy with 90% platinum and 10% iridium. So meter is the distance between two marks drawn on a platinum iridium rod kept at 0 degrees Celsius in the International Bureau of Weights and Measurements at Service near Paris. So this particular rod on which two marks have been kept, the distance in between those two marks has been taken as the standard measurement of 1 meter. 1 meter has another definition as well. 1 meter is the distance which light travels in 1 by 299,792,458 of a second in air or vacuum. So as you can see, if we approximate the speed of light in air to be 3 into 10 to the power 8 meters per second, then we can say that 1 meter is the distance which light travels in 1 by 3 into 10 to the power 8th of a second in air or vacuum. Similarly, SI system defines mass as well. Mass is measured in kilograms, which is the unit. So how is kilogram defined? Kilogram is the mass, or 1 kilogram is the mass of a cylindrical piece of platinum iridium alloy kept in the International Bureau of Weights and Measures at Sèvres near Paris. So that particular cylindrical rod of platinum iridium alloy that is kept at the International Bureau of Weights and Measures is known as 1 kilogram as defined by the SI system. Let us come to the other fundamental unit, that is time. Now in SI system, the unit of time is taken as second. So how does the SI system define 1 second? 1 second is defined as 1 by 86,400th part of the time which is taken by the earth to complete one rotation on its own axis. 86,400 is nothing but the seconds in a day. So if it's completing one rotation about its own axis, it means one day is being completed. So 1 by 86,400th part of that time will give us 1 second. And this is how second is defined in the SI system. So now let us try to calculate and find out the diameter of the nib of the pencil. Now in order to measure the diameter of the nib, do you think we can use meters? SI system says that meters is the standard for international measurements. Now if we want to use meters in this case, it would be impossible to do so because it would be very inconvenient. So in order to make such measurements easy, we have certain subunits of meter. Subunits of meter, first we study about centimeter. Centimeter is 1/100th part of a meter. So if we divide 1 meter, let's say, into 100 parts, 100 equal parts, then we get each part as 1 centimeter. Similarly, we define millimeter as 1,000th part of a meter. So if we divide 1 meter into 1,000 equal parts, then each part would have a length of 1 millimeter. Moving on, we also have a micron. A micron is 1 millionth part of a meter, and micron is usually used for measurements on the atomic level. So micron is nothing but 10 to the power minus 6 meters, or in other words, 1 by 1 millionth of a meter. Nanometer is defined as the 10 to the power 9th part of a meter. Now nanometer goes even further, and it is mostly used for measurements of wavelengths of light. So as you can see, 1 nanometer is equal to 10 to the power minus 9 meters, or in other words, 1 by 10 to the power 9th of a meter, or the 1 by 10 to the power 9th part of a meter. Now let's say we want to calculate and find out the distance in between Calcutta and Delhi. Now do you think we can use centimeters or millimeters to do so? The answer is no, because it would be very inconvenient. Even if we were to use meters, we would find that it is inconvenient in that case as well. So if the SI unit and the subunits of it in length fail, what do we use? In that case, we use multiple units of a meter. So in this case, if we have to measure the distance in between Calcutta and Delhi, we can do so with the help of kilometer. Kilometer is the 1000 multiple of a meter. Or in other words, if we multiply 1 meter with 1000, we get 1000 meters, which is equal to 1 kilometer. Now we come to the other fundamental unit, mass. So over here we have measured the mass of the ball as 0.058 kg, because kg is the SI unit. Now for a layman, 0.058 would make very little sense. So instead of measuring it and expressing it in kgs, how else can we express it? We can express the mass of this ball in its subunits. So the mass of this particular ball was found out to be 58 grams. So gram is that subunit of kilogram, which is 1000th part of it. So if I take 1 kilogram and I consider 1000th part of it, that would give me 1 gram. Similarly, milligram is 1 millionth part of a kilogram, or in other words 1 by 10 to the power 6, which gives us 1 mg as 10 to the power minus 6 kilograms. We also have multiple units of kilograms if we have to measure heavier objects. We have a quintal, which is 100 times a kilogram. 1 quintal equals 100 kgs. And we also have a metric ton, which is 1000 times a kilogram. 1 metric ton being 1000 kgs. So if we have to measure the weight of vehicles, we use these multiple units of kilogram. Let me tell you an interesting fact. The fact is that the time taken by Earth to complete one round around the sun, or one complete revolution around the sun, is given by 31557600 seconds. So this is the amount of time that it takes the Earth to complete one revolution. Now if I am to say this to a layman, that one revolution of the Earth around the sun takes this much time, what sense will he be able to make of it? None at all. So in order to avoid this, we have certain multiple units of time as well. Minute is defined as a duration of 60 seconds. So if I consider 60 seconds, it will give me 1 minute. Similarly, an hour is defined as 60 minutes. So if I have to express 1 hour in terms of seconds, it will be 60 into 60 equals to 3600 seconds. Why? Because an hour contains 60 minutes and each minute in turn contains 60 seconds. Likewise, a day is defined as the duration of 24 hours. So 1 day is equal to 24 hours. We have further multiple units. A year is defined as 365 days. A decade is defined as 10 years. A century is defined as 100 years. And a millennium is known as 1000 years. So if a person were to ask that how much time does it take the Earth to complete one complete revolution around the sun, the answer would be 365 days or 1 year.